horrible on the nomenclature. There's not, we're not trying to trick you into any of these crazy exceptions to octet rules. But let's just take a minute, look back at our periodic table, and understand why some things form cations and some things form the anion. Okay? Now remember, when you're writing a formula, you always write the cation first and the anion second. Okay? So whatever forms your positive charge comes first, whatever has your negative charge comes second. Now, we talked a little bit about the octet rule. Remember, most things want to have an octet okay, meaning 8 electrons in the outermost energy level. There are some exceptions, like remember sulfur, when we were drawing Lewis structures, can have, it can form 6 bonds and have 12 electrons surrounding it. Then you've got things like aluminum that can form 3 bonds and have 6 electrons surrounding it. But again, we don't have to get real heavy with these Lewis structures or anything, but I do just want you to remember a couple basic things. So let's take a look at, let's say something like calcium. Calcium forms a +2 charge, and so the electron configuration for calcium is going to be 1s2 on that first energy level, 1s2. The second energy level is going to have a 2s2 and a 2p6. Okay, so calcium, first energy level 1s2, second energy level 2s2, 2p6. Third energy level is going to be 4s2. I'm lying to you. The third energy level is going to be 3s2. Okay? Okay, so third energy level, 3s2, 3p6. Okay? The fourth energy level is going to be 4s2. So notice that if we get rid of these 2 valence electrons here, calcium becomes a +2 charge. And if we lose these 2 electrons, that means that I have an octet on my third energy level, which is right below it, which now becomes that outermost. Okay, so sometimes it's hard to understand when you're losing 2, how are you meeting that octet rule? Or if you're losing 1, how are you meeting the octet rule? Well, you're meeting the octet rule because the energy level below it has an octet now in its outermost energy level. Okay, so let's say that we wanted to write the formula for something like calcium fluoride. Okay, calcium, remember, it is only going to form 1 oxidation number because it has a +2 charge. Okay, remember these 2 families aluminum, silver, and zinc, they are not multivalent. They form one oxidation number. All of these things in here, all of these other things, they have the ability to form multiple oxidation numbers. These transition metals, okay? You know, you've got some kinky stuff here. If you are a transition metal, now we commonly refer to these up here. Everybody's heard titanium, vanadium, chromium, manganese, iron, copper, nickel. We always use these here. You know, zinc, remember, is an exception. It's only going to be a +2 charge. Silver is only going to be a +1 charge. Okay, but all of these other ones here, your yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, cadmium, they can have multiple valences. So they're not having to satisfy this octet rule. Your lanthanum, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, gold, mercury, all these things right here, they do not have to fulfill that octet rule in the same way. What they do is they move those, they have multiple oxidation numbers, and they're moving those d electrons back and forth to different places so that they can achieve, you know, sometimes a half stability kind of a thing. All right? And then take a look over here at these noble gases. They're full, they're happy, so they're not going to go adding or subtracting any electrons to meet the octet rule. So when it comes to meeting the octet rule, remember, these right here, these are happy, so they're not going to do anything. Your noble gases are also called inert gases. They're very hard to react because their octets are full. They don't have to do anything in order to meet their octet rule. These right here, they're multivalent metals, and so, you know, sometimes they don't follow all the rules that as you would like them to follow. But these two families here, you know, anything in these two families, these are really easy families. They like to give up electrons in order to follow their octet rule. And by giving up electrons, the energy level that is beneath them is satisfied. Okay, so calcium is a trusty monovalent ion. It forms a +2 charge. Fluoride, remember IDE, this is monatomic. This is fluorine in its monatomic state. And if you're forming a compound, the charges have to be balanced out to 0 or be neutral. Okay? So the least common multiple between a +2 and a -1 is going to be a 2. So if you take 2 of these, 2 times -1 gives you a -2, and 1 of these, 1 times +2 gives you a +2, your charges equal out to 0. So the formula for calcium fluoride is CaF2. So I gave you some handouts to practice writing formulas, and I do suggest you go back and write formulas, but you can spend days and days practicing formulas. At this point, I wouldn't spend days and days practicing formulas because you got like 2 days left. I would just remember how to, just remember some basics, go back and try a few of them. But I don't think that that's going to, by practicing writing your formulas over and over and over again and spending hours writing formulas, I don't think that that's where you're going to get as much bang for your buck. Okay, so practice a few of them. Come in, I'll check them for you. But we do need to move on to some of this new stuff that we've been doing that takes a little bit more time.